Let's close this section by looking at some interesting, thought-provoking ideas about trigonometry. This first one says to use a calculator to verify this relationship, that the sine of 49.3 divided by the cosine of 49.3 is equal to the tangent of 49.3. So let's do it. So the sine of 49.3 divided by the cosine of 49.3 is equal to this number. Let's compare that to the tangent of the very same angle, 49.3. Son of a gun, same thing. I wonder why. Well, there's this thing called the trigonometric identities, and we study those in trigonometry pre-calculus and use it in calculus. And the trigonometry identities say that the sine of an angle divided by the cosine of an angle will always be equal to the tangent of the same angle. Here's why in terms of x, y's, and r's. The sine of theta, right here, we have described as y divided by r. The cosine of theta we have described as x divided by r. When you take two fractions and divide them, you multiply by the reciprocal. So you take the first fraction, y over r, leave it alone, and multiply by the reciprocal of the second fraction, which would be r over x instead of x over r. And in this process, r divided by r is equal to 1. So you are left with y divided by x. Well, y divided by x is just the tangent of an angle. That's the definition. So one of the many trigonometric identities says that the sine of an angle divided by the cosine of an angle will be equal to the tangent of the same angle because of these definitions. I'm going to ask you from time to time to explain why, so you really get a feel for trigonometry. So why is the value of secant theta never less than 1? Would you please remember that these trig functions are based on a right triangle that I'm speaking about, this acute angle theta. This is in standard position, if you will. There's x, y, and here's r. I always like to remind you that the cosine of theta is x over r, and therefore the secant is its reciprocal, which is r over x. Would you look at this picture over here in this right triangle? The hypotenuse, which is opposite the right angle, is always the largest side in a right triangle because this is the largest angle in the triangle. These are always acute, or less than 90 degrees, and they add to be 90 degrees. So this being the largest angle, this is always the largest side. If you have the largest side divided by a smaller side, you're always going to have a number that's greater than 1. So never less than 1. Likewise, I might say to you, why is cosine always less than 1? And it can be equal to 1, less than or equal to 1. And that's because the hypotenuse is in the denominator. So if you have a leg, this leg of the right triangle is always smaller unless you're on a quadrantal angle, 0, 90, 180, 270, 360. This is always smaller than that. So with this being smaller than the hypotenuse, the value for cosine would always be less than 1. You know, real quick, check this. So cosine of 10 degrees, less than 1. Cosine of 25 degrees, less than 1. Cosine of 51 degrees, I'm just picking these numbers, less than 1. Cosine of 76 degrees, I'm getting bigger, less than 1. Cosine of 82 degrees, less than 1. Cosine of 87 degrees, less than 1. So it's because you have the leg divided by the hypotenuse. All right. Explain for me why the tangent can equal any positive real number. And so I just want you to envision two possibilities for theta. Theta can be less than 45 degrees and greater than 45 degrees. With tangent being defined as y divided by x, when theta is less than 45 degrees, then y is smaller than x. When theta is 45 degrees, wish I was using straight lines here, but when theta is 45 degrees, y and x have the same value, so that would be equal to 1. And then finally, when theta is greater than 45 degrees, here's theta, greater than 45 degrees, tangent is y divided by x, then this side is bigger than this side, and it can just go into infinity because, you know, you could get to an 88.888 degree angle. And so this side opposite right there, this y value is much bigger than that x value. Okay, let's go ahead now and do a few more problems that digs just a little bit deeper. So we have learned how to find theta given a ratio on our calculator. But this problem says find the sine of theta, not theta, but find the sine of theta. So once you know theta, you'll hit the sine button and then the angle to get the answer to this problem. But it's given that cosine theta is this 0.625. So to find theta with this given information, the steps that I take with my calculator is to go second cosine 0.6275 and find out what that angle is. So second cosine 0.6275, and I find out that that's a 51 degree angle. And then the problem asks me to find the sine of theta. So now that I know what theta is, I take the sine of that 51.1 degree angle. So I'm just going to hit the sine button and go second answer. The answer, I'm going to move my calculator up. You can't see this. The answer button is right here above this negative sign. I use it frequently. So I went second, and then, because this is in blue, that's why I went second, and then answer. To pull up the 51.1340830 degrees, then it will give me the sine of that full angle. And I get 0.779. So the answer to this problem is 0.779. So I'm just asking you to practice using your calculator. So if I want to find the cosecant of theta, I got to find theta given cosine theta is this value. So to find theta, I'll go second cosine, and then I'll get the size of that angle. Let's go ahead and do that. 0.1063. Hard to 0.1063. Hopefully I put in the right numbers. So second cosine of 0.1063 gives me an 83.9 degree angle. Now remember, to find the cosecant of theta, cosecant and sine are reciprocal functions. So I could find the sine of theta and then just flip it. So hit that x to the -1 button, because I got to find the sine of it, and essentially I'm finding 1 over the sine of 83.9 degrees. That's another way to do it. So your choice. So I'm just going to go sine of that answer and find out what that is, and then I'm just going to flip it to get the cosecant. So again, a number bigger than 1 because cosecant has the hypotenuse in the numerator. 1.006 is my solution to this. Okay, finally, this is how, this next problem, a submarine dives such that a horizontal distance, h, it moves, and the vertical distance, v, it dives, are related by this equation, this formula. And this is kind of a physics thought, and we'll develop this towards the end of this chapter. Here, theta is the angle of the dive. I want you to find theta if I know that the submarine goes horizontally 2.35 miles and vertically 1.52 miles. I believe you can see, I know you can see, so let's see, vertically the submarine goes 1.52 miles. Let's just put an arrowhead here, 1.52, and horizontally it goes down 2.35 miles. And I want to find the angle of the dive. That's what I want to find. And this formula is telling you that you can find that angle of the dive using this by putting the vertical in here and the horizontal in there. So I'm going to write my formula down. So V equals H times the tangent of theta. And so I'm actually, I'll go ahead and put V in. So I'll put 1.52 in for V. I'll put 2.35 in for h, and then to get the tangent of theta all alone so that I can solve for theta, algebraically I'm going to divide both sides by 2.35. So now I have the tangent of theta is equal to 1.52 divided by 2.35. And to find theta, I'm going to go second tan. That's how I find an angle when I know this ratio of 1.52 divided by 2.35. Let's just do that real quick. 1.52 and 2.35. 1.52 divided by 2.35. That ratio will tell me that the angle of the dive is 32.9 degrees. So theta, 32.9 degrees based on